Hi, today we are going to see the expression for work done in adiabatic process. Okay, adiabatic process, the expression is PV power gamma is equal to constant, where gamma is called adiabatic constant. It is called Cp by Cv, specific heat at constant pressure divided by specific heat at constant volume. Okay, now what is work done basically? Work done is equal to integration of all small works. So this can be written as P dV. Work is P into change in volume, pressure into change in volume, from let us say volume V1 to V2. So we're going to use this expression because we cannot integrate this. We are going to use this expression. So from here we can write dV divided by C into C divided by we can write V power gamma from V1 to V2. So we have to integrate this expression now. So we know that integration of this will be V power 1 minus gamma by 1 minus gamma. You know that integration of x power n dx is equal to x power n plus 1 by n plus 1. So using that formula we are doing that. So that constant C we have to multiply. The lower and upper boundaries are V1 to V2. So now we will put the values here of the upper and the lower boundaries. So CV2 to the power of 1 minus gamma minus CV1 to the power of 1 minus gamma divided by 1 minus gamma. So because we want to eliminate this C, this is our expression was PV power gamma is equal to constant. So I can write P1 V1 to the power of gamma is equal to P2 V2 to the power of gamma is equal to constant. These are different stages of that thermodynamic process. Okay, so because V2 is there here, I will write C as P2 V2 multiplied by V2 to the power of 1 minus gamma minus, because V1 is there here, P1 V1 to the power of gamma multiplied by V1 to the power of 1 minus gamma divided by 1 minus gamma. You can see here that this is V2 to the power of gamma. So when you add the powers of V2, this minus gamma plus gamma will be eliminated. So you are left with P2 V2, and here also P1 V1 to the divided by 1 minus gamma. So this is one expression to find out. Because this is a ideal gas, so PV is equal to nRT. So we can write P1 V1 is equal to P2 V2. And in terms of temperature, if you want to write, we can write the same expression as nRT2 minus nRT1 divided by 1 minus gamma, or that is equal to nR into T2 minus T1 by 1 minus gamma. So this is another expression to find the work done by adiabatic process. One expression is this, one expression is this.